All right, welcome back to the drive-through, boys and girls. Sponsored as always by the deli. Hungry? Stop by the deli. Get yourself a fresh mozzarella sandwich with lettuce and barbecue sauce and hot sauce on a baguette. Exactly. All right. Our final section in Chapter 4, this is Chapter 4-6. The title is Slope, but what we're really trying to do is connect slope with geometry. So slope was a critical part of your class last year. So let's look at 4 different examples, okay? Slope describes the path of a line as it moves to the right. All right, that's one way you can think of it. So, as this line moves to the right, it is increasing. So, as it moves positive in the x direction, it moves positive in the y direction, and therefore this has a positive slope. And this one has a negative slope. I think most of you guys understand that. You might have needed to be refreshed, but I think you understand that. Here are the two that people get confused a lot. So, what I want you to think about is, could you walk on this line? Could you walk on it? Yes, you could. Absolutely you could. I'm walking on a similar line right now. Would you consider this to be uphill? Probably not. Would you consider it to be downhill? Probably not. So this slope is 0. It exists, but it is not positive and is not negative. And what's a number that we represent that is neither positive nor negative? It is 0. Okay? This slope, okay, you could not walk on that line unless you were a bug or had climbing gear. And then you wouldn't be walking, you'd be climbing. Okay? So, to remember that, that's how I remember it. If I can't walk on it, it does not have a slope. Okay? This slope does not exist. All right, let's keep talking about slope. On a line that is represented by y equals mx plus b, for example, y equals 3x plus 9. That's a common way to represent a line, and in this case, the slope is equal to m. So m is one way that we represent slope. Another way is change in y. Well, in math, we use the Greek letter delta to represent change. So change in y over change in x is another way we write slope. But the real way we find change, hi, welcome to the drive-thru. Can I take your order? Yeah, I'd like a large ham sandwich with Swiss. Well, that'll be $7.35. Out of 10? $2 and, oh geez, $2.65 is your change. You subtract. That's how you find change. So it's equal to y1 minus y2 over x1 minus x2 if we had 2 points. But we could also find it by doing y2 minus y1 over x2 minus x1. So all of those things represent slope. Okay, so let's go back to our vertical line. I don't know. Let's say this is on this plane right here. And we've got a point on this line is 6, 10. And this is the point 6, 4. So we would do change in y. Slope is equal to 10 minus 4 divided by 6 minus 6. That is 6 on the top divided by 0. Not allowed to divide by 0 in life. The answer is infinitely big, so we just call it undefined. So now I have mathematically showed why a vertical line has an undefined slope. So hopefully that helps. So remember, this is your slope formula. All right, all that review. Now let's talk about lines, okay? Okay. So, we already stated that a line can be described as y equals mx plus b. It can also be described as y minus y1 equals m times x minus x1. It can also be described as ax plus by equals c. Those are all different forms of lines. Let's use the most common one. Let's think about the line y equals negative 2x plus 6. Okay, well, if I put in a 0, I get a 6. If I put in a 1, I get a 4. If I put in a 2, I get a 2. If I put in a 3, I get a 0. If I put in a 4, I get a negative 2. If I put in a 5, I get a negative 4. You can see what I'm doing here. Hopefully, I'm annoying you guys, okay? Because I want you to understand when you graph a line what the heck it is that you're doing. The thing is, we've gone over this in this class, so we're ready for this now. How many points satisfy this equation? Infinitely many points. Can we graph infinitely many points? We cannot. So what do? We come up with this object that's called a line, okay? It tells me I screwed up some of these points up there. Yep. All right, so let's go back and examine. Left 1 up 2. Left, there we go, there we go, there we go. Okay, so look, that line represents all of the points because it has arrows that satisfy this equation. What defines a line? Two things. What is the slope of the line, and where does it hit the y-axis, our y-intercept, okay? Now, we could pick other things to define a line, but if we know a line's slope and we know its y-intercept, then we know what the line is. We could also define a line just by getting 2 points. So if we had a point here, and let's say a point here. All right, well, this point is left -8, +4. And this line is -3, +5. Okay, so let's find the slope of that line. Well, let's graph the line first. I mean, why not? This is America. This is going to look a little awkward, but there we go. All right, so there's our line. Okay, now notice it's got a non-integral value for a y-intercept. Okay, the slope, well, since we graphed it, we could just go rise over run. It's up 1 over 1, 2, 3, 4, 5. The slope is 1/5. All right, what if I didn't want to count? Well, you could do 5 minus 4 over -3 minus a -8, and we do minus a negative. It turns into a positive, and that's 1/5. Okay, good, that works. So if I wanted to find the y-intercept, I could just use, let's say, this point, and I could say 5 is our y, equals 1/5 times x, -3, plus b, and you get 5 equals -3/5 plus b. Add 3/5, and you get 5 3/5 is equal to b. I buy that. Looks like 5 3/5 to me. Okay? So this red line has the equation y equals 1/5 x plus 5 3/5. That's the equation of the red line. All right, good. Moving on. Now let's talk about parallel lines. Okay, how about that line? Oops, hold on. Didn't mean to let go of that button. And that one. Okay? Those lines appear to be parallel. What's the definition of a parallel line? Well, you got to watch yesterday's video or just listen. I'll tell you again. Parallel lines are two coplanar lines that never intersect. Okay, what makes a line parallel is indeed their slope. So if I grab this point and I went rise over run, the slope of this line is 1/2. The slope of this line, this isn't perfect, but it's just a little off, but the slope is also 1/2. Look, up 1 over 2. Rise over run, and that never changes. Look, it's just like steps. That's why they call them risers. Okay? So, since these two lines have the same slope, they are deemed to be parallel. You can see that they're a little bit off, but hopefully you understand that concept. Okay? All right, moving on. So, now let's talk about perpendicular lines. So what I'm going to do here is I'm going to try to start with two lines that are indeed perpendicular to each other. You know what? I want to use a straight edge instead. I don't like this line tool right now. By the way, you might want to use a straight edge for this section. You will find it to be extremely useful. So let's start there. And let's do this. There we go. Okay. Let's change to blue. Okay. That green line appears to be perpendicular with the blue line. But we can't just go on appearance. This is math. Maybe that's why, like, math teachers are so ugly. Okay, I shouldn't have said that. So, let's find the slope of the green line. Let's see. This is, well, let's just count it. Over 1, up 2. It's rise over run. It's positive slope. So the slope of the green line is 2 over 1. Okay? Let's find some points on this blue line that are at a whole value. There's this, and let's say there's this one. Okay, the blue line is negative. This is a -3. Oh, bummer. So that's why they're not exactly. Let's see. No, hold on. Let me choose a different set of points here. Because I don't know how that happened. But if I look at this, okay, I see how it's just a little off. All right, let's look at this. This is a -1 and a 2. So the slope of the blue line is -1/2. Now look at this number and compare it to this number. Hopefully you remember the term reciprocals. Okay? A reciprocal is when you take a fraction and flip it. Okay? Now these aren't just reciprocals, they are opposite reciprocals, meaning one of them is positive and one of them is negative. So, the rule is if two lines are perpendicular, then those two lines have slopes that are opposite reciprocals. Okay? you some time to write that down, and then we're going to do an example, and that'll be the end of the video. Okay, so triangle HOT has coordinates, and they're given to you. They want us to find the altitude and the median. So now you'll see that this is going to start being applied to geometry. So let's graph it right. H is left 4, up 3. Okay. O is left 2, up 10. And T is right 6, up 5. Okay, it says find the altitude and the median drawn from point, oh, that's not what I meant to say. Find the slopes of the altitude and the median drawn from point O. So, well, let's think. I think I'm going to find the slope of the median first, because that one's easier. Where does the median go? The median connects to the opposite side's midpoint. So the midpoint, if this is negative 4, 3, and this is 6, 5, the midpoint is the average point. So the average of 6 and negative 4 is 1, right? Okay. That doesn't look right, but we'll just go with it. And the average of 5 and 3 is 4. So it's actually going to be a... What have I done wrong here? No, that's completely wrong. Sorry. 6, 5 and negative 2, 10. That's better. 6 plus negative 2 is 4. 4 divided by 2 is 2. 5 plus 10 is 15, and that makes more sense. Okay, so that is the midpoint. Okay, O is negative 4, 3. Come on. So, to find the slope of the median, equals, well, it'll be 7.5 minus 3 over 2 minus a negative 4, which is a 2 plus 4. So it's 4.5 over 6. If I double that, I get 9/12, which equals 3/4. So the slope of the median is 3/4. Now let's find the slope of the altitude. Well, as it turns out, the slope of the altitude is actually easier. Okay? The slope, well, the altitude is going to look something like this. I don't know exactly where it's going to hit, but I know it's going to form a right angle. Oh, it forms a right angle. That means it's perpendicular. So to find the slope of the pink line, which is the slope of the altitude, I just need to find the slope of the blue line and then find the opposite reciprocal. So let's do just a little timeout here. And let's do some work. Well, let's find the slope of MT, or sorry, the slope of HT. Well, that's going to be 10 minus 5 over negative 2 minus 6. So that is 5 over negative 8. I believe that because the blue line certainly has a negative slope, which means the slope of the pink line must be the opposite reciprocal to that, so it is 8/5. And that is that. Have a good night. Boom!